Hello and welcome to uh, the beginning of maybe the ending of the small chapter phenols. And this is the big chapter alcohols, phenols, and ethers. They're quite related, but phenols are aromatic compounds while alcohols are aliphatic compounds. Carbon is sp3 hybridized, which bonds with the OH group, while in phenols, carbon is sp2 hybridized, which bonds to OH. And ether are relatives of both. It can be aromatic, it can be aliphatic, because it can be containing two alkyl groups, maybe two aryl groups like diphenyl ether, or one alkyl, one aryl, phenyl ethyl ether, or methyl phenyl ether, that is methoxy benzene or anisole. Good morning, Samidha. We are now going to begin the chemistry of phenols. Before that, let me give you some roadmap problem based on alcohols, just to make sure that your preparations are uh, up to date. Mm, oh, this is H. Sorry, this ZHIJ, this is K, this is L. You always give the measure product. That's it. Let me not extend beyond this. So quickly apply your knowledge of whatever we have learned so far to. Oh, sorry, Mr. Rudra, I could not find time to look to question number 32, I guess.
Yes, sir.
Yeah,
Yes, sir.
I will do that. A, B, C, D. Since we are now recording this program, so we will not while away more time on waiting, because I find that the video is being watched by some interested guys. We are not very keen in promoting the videos, but if we do it for guys like Rudra, Samidha, then why that video be not recorded and come to the use of others? So, what is A? Therefore, I am just becoming impatient to go to the uh, answers. I mean, to the what is A?
Sir, halogen
This will be,
chlorine legume.
tell the name, isobutyl chloride, right? Sorry,
Yes, yes, sir.
isopropyl,
Yes, sir.
isopropyl,
Propylene. Yes, sir.
isopropyl chloride. Then what is B? What is Samhita? What is B? It is the corresponding Grignard reagent. Mg will be inserted between carbon chlorine bond and it will form Grignard reagent, which will give a carbanionic alkyl group for nucleophilic attack. Now this is nothing but this MgCl. This is the Grignard reagent that we are producing. And what is C? Any Grignard reagent with formaldehyde will give which alcohol? Rudra? Any Grignard reagent with formaldehyde will give which alcohol? Which type of alcohol? Which type of alcohol?
Primary.
Primary alcohol. You are not, doing practice. So this is C, Samida. This is formaldehyde. So this isopropyl group will come, will have a nucleophilic attack, and this is the nucleophilic addition, and then this will be hydrolyzed to OH. So this will be CS2OH. So I told you when formaldehyde is there, you just attach the alkyl group of Grignard reagent with CH2OH. This becomes CS2OH. I don't have a space here. Okay, let me try CH2OH. This is isobutyl alcohol. So C is isobutyl alcohol, and then let us go in the direction of D. Then with SOCl2, of course, here there is no room for any uh, retention of configuration. There is no chiral center here. Simply it will substitute OH by chlorine. So D will be isobutyl chloride. This was isobutyl alcohol. This will be isobutyl chloride. And this will be an SN2, 1 degree, and this is strong base. And this will be SN2. So it will be getting isobutyl cyanide. Or in the IUPAC language, it is 1, 2, 3, 4, 3-methyl butane nitrile. But more popularly, since isobutyl group is very popular, isobutyl cyanide. And let me tell you, before we come to study carboxylic acids and derivatives, cyanides on acid hydrolysis, H3O plus produces carboxylic acid. So this C becomes carboxylic acid. I give you because next time when I put my roadmap problem, I might, you know, put this. In acidic hydrolysis, it will give you COOH, and this ammonia, this becomes ammonia, but ammonia cannot escape in acidic medium. It will become ammonium salt NH4 plus. Doesn't matter. We will be knowing only this cyanide. Cyanides are prepared only to get derivatives. Maybe most important among them is carboxylic acid. You can convert it to convert this to amine, primary amine, after getting carboxylic acid. You can convert it to aldehyde. We shall see cyanide can be directly converted to aldehydes, carboxylic acids, amines. Therefore, cyanides are very important compounds for, though extremely poisonous, but once you convert it to carboxylic acid, it's not that poisonous as cyanides are. Now, coming to the direction of F down, this sodium, this will be sodium salt because alcohols ONA, that is F, sodium isobutoxide, and then that with a primary because this is Williamson synthesis. So this will be ASN2 Williamson synthesis, a primary halide, CS2. Then this O will attack. This O minus is the O, then CS2, CH, CS3, CS3. This ethyl isobutyl ether. And then the other one, H, what will be H? Yes, anyone?
Elimination.
Huh? Elimination will happen
Elimination.
because any alkoxide ion being a strong base will go for the beta elimination. So it will be isobutene. Of course, another organic compound will be produced. So here you have to write down. I should have written H plus something. So equimolar quantity of this will be formed. This will be CH2OH because O minus will pick up H plus from the beta position and it will be OH. So this will be nearly the 100% reaction elimination with a strong base and with a 3-degree halide. Of course, we take alcoholic medium. There is no doubt about it because these compounds are hefty. They are not soluble in water. So maybe we can add a little bit of water to increase the polarity if we are thinking of SN1. But why? If elimination is the major product, so why to sabotage by giving some room for substitution, SN1 substitution? So this is the measure. And coming to this direction, which to I, of course, this is the Jones reagent, which is a strong oxidizing agent. You cannot control in this situation. You have to go to the last station. Don't stay at the aldehyde station. Go up to the carboxylic station. So what we write here is carboxylic acid. CH3, CH3, CH, COOH. But here PCC I have given you here, that will definitely arrest the reaction in the stage of aldehyde. We again, I think this aldehyde was somewhere in the, no, 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 there is no aldehyde here. This is isobutyraldehyde or 2-methyl propanol, and that is J. And this again, this ethyl with aldehyde, I told you with formaldehyde it will give you primary. With any other aldehyde, samidha, it will give you 2-degree alcohol. This will go. So K is, this is CH, then CHOH, and this ethyl will be connected here. Let me write down CS2, CS3. So this will be a secondary alcohol, Grignard reagent reacting with any other aldehyde. And then, oh, I've told you that I forgot. I thought that I'll be making a 3-degree alcohol and copper heat will give you an alkene, but ultimately it became a 2-degree alcohol, which will undergo dehydrogenation to give you the corresponding ketone. Just like you are doing this with Jones reagent, whatever would have happened for secondary alcohol, same thing will happen with copper heat, but it will be dehydrogenation. Had it been a 3-degree alcohol, then we get an alkene, more substituted alkene containing same number of carbon atoms. Because there will be no 3-degree alcohols, they are susceptible to normal oxidation by any oxidizing agent, but here there is no oxidizing agent. It is simply a catalyst, copper. What will happen on the surface of copper catalyst, that is an adsorption and then a desorption process, where simply dehydrogenation will not take place, rather dehydration will take place, and you get an alkene. So I think with this much of revision, we would not waste our time to start phenols. And I have a resolve. Ms. Samita, when are you going to leave the class or your school?
The 6:45.
Okay, this is in my watch, it is 5:36. And 6:45 is 1 hour ahead. So within that 1 hour, we'll be able to finish phenols. Now, you can name a substituted phenol. If this is phenol, then this is what? And this is what? I have to put a group which is inferior, which is a type C, which is a type C group which is having lower priority, or type A group which has no priority. So I can make it this one. Otherwise, I cannot tell it as phenol. I have to tell it as benzaldehyde, benzoic acid, or something like that. So, what will be the name of this compound? This is phenol. This is what?
Cresol.
Which cresol? Cresols, there are
Meta.
three. You say that. The trivial name is metacresol, but the IUPAC name will be 3-methylphenol. Or it is metacresol. And what is this? Samita?
Ho.
Samita? I have not heard you since the beginning of the class. So I have some apprehension in a lighter vein. Are you dozing? Oh, I'm sorry. Samita
No, sir.
is my granddaughter. So, what?
So, 3-methoxyphenol.
Are you kidding me? How it is 3-methoxy? 1, 2, 3, 4. Are you not numbering? So
Sorry,
tell.
sir. 4-methoxyphenol.
Yes. 4-methoxyphenol. Yes, precisely correct. And it has no trivial name. Had it been only methoxybenzene, it would have been called anisole. But here, there is no such trivial name. And what is this? Once again, Rudra?
Orthonitrophenol.
Yes, you can call it orthonitro, or correctly, the preferred IUPAC name is 2-nitrophenol. Phenolic compounds are distinct, and this is not a phenolic compound. Let me tell you, although it carries a benzene ring, this is not a phenolic compound. This is an alcohol. Showing all properties of alcohol, its acidic property is much lesser, much lower than phenolic compounds, because this is bonded to sp3. What is the name of this compound? Both
Ben-
popular name and IUPAC name. Yeah.
Benzyl.
Yes, it is a benzyl alcohol. It is not an aromatic alcohol. It is an aliphatic alcohol, sp3, and this is sp2. All are sp2. So the distinct difference in the properties that this will not give, this will not dissolve in sodium hydroxide. There will be no reaction, but any phenolic compound will dissolve in sodium hydroxide, forming the salt. Here, sodium hydroxide will not form the salt, although the metallic sodium will form the salt in both the cases. And we will find there are many differences in their chemical and physical properties. This is because it belongs to alcohol type. It's easily it will undergo substitution by PCl5, PCl3, where phenolic compounds, they do not undergo such PCl5, PCl3 associated type of substitution, and many other unique property of phenolic compound will not be found here. You will not find any violet color with ferric chloride. The most distinguishing experiment to distinguish between phenolic compounds and alcohols is the ferric chloride test. If you add a drop or 2 drops of freshly prepared ferric chloride, then you get a violet color with phenolic compounds, except nitrophenols produce green. But such violet coloration or green coloration won't be found in alcohols. It will remain as such, no change of color, so same reddish brown color of ferric chloride will not change. But on the other hand, ceric ammonium nitrate, as we discussed last time, ceric ammonium nitrate will give a red color with alcohols, won't give any red color with phenolic compounds. So that will prove beyond any doubt. Now coming to the preparation, I would like to use the uh, PowerPoint screen to quickly, and I will give you the home task to write down at the phenol is also called carbolic acid. Its trivial name, or phenylic acid. This is a very trivial, most trivial name, phenylic acid. It is not benzoic acid, it is phenylic acid or phenic acid. So there are so many other nicknames, but most popular name is phenol. And coming to methods of preparation, it is easily prepared from benzene sulfonic acid. And benzene sulfonic acid is easily prepared by electrophilic substitution, ARSE. Benzene with fuming sulfuric acid will give you benzene sulfuric acid. And then you fuse with sodium hydroxide solid and heat it. That will eliminate SO2, SO3 2 minus is the leaving group. OH will be the, this will be a SN, AR-SN reaction. AR-SN reaction, OH will come here. But since it is alkaline medium, it will remain ultimately in the form of salt. And then you have to make acidification to convert sodium phenoxide into phenol. Write down this. I'm giving you 1 minute, 1.5 minutes time.
Thinking about self-publishing but unsure what you've heard, let
Done? So make sure the guy and the girl, I will say Gigi, guy and girl, please raise your hands once you finish writing. Otherwise, it will be a wastage of time because we have made a target to come to the end of phenol by the time our clock strikes 6:45. BSA, that is BSA is not Bata Su, Bata So, BSA, Jota Thila, Bata Showroom, no, BSC, sorry. Benzene sulfonic acid is prepared from benzene, that is ARSE, and this is ARSN, phenol salt. Phenol salt is formed. Of course, first phenol, then phenolic salt. Not ONA minus or something like that is the nucleophile. Nucleophile is OH minus. And then it remains in the form of salt, sodium phenoxide. Over.
Yes, sir.
Not showing. Rudra?
Yes, sir.
Now coming to the next one, which is a not very popular method from chlorobenzene. We know how ARSN is not really happening. It is the sign substitution, elimination followed by addition. It looks like ARSN, but unless there is, of course, you might ask that what is the real nature of this. This is a very good living group. That is why the mechanism can be in favor of ARSN rather than sign substitution. But here it has been found with a labeling study that pure chlorobenzene, if it is subjected to the substitution, you will find that OH group will be attached to the labeled carbon 50% and non-labeled carbon 50%. But I have not confirmed the actual mechanism operating when there is no other minus R group in the orthopara position in case of sulfonic acid. But here this is proved beyond doubt. It is sign substitution. You get first salt because it is in the medium, alkaline medium, and then you acidify to produce phenol. Write down. This is not a very popular method. It's not quantitative. It goes via benzene intermediate. A triple bond in benzene is called benzene. It's a very unstable intermediate. This is morning. We guys who are watching the video now. This is a morning class that is being recorded. 5 o'clock. Today it was a bit delay because I got up late from the bed. And therefore, but since it is a morning class, there is every chance that the guys who are, the Gigi, the guy and a girl who are there with me might be today. But there are many more who have remained absent. Might feel drowsy. And if you write, then the drowsiness is bound to vanish. Over. This we have already done in chlorobenzene. So I think we will leave a space. Those which have already done, we will not write here. Okay, done?
Yes, sir.
Yes, sir.
Now this is the most important thing. And since you guys are IIT advanced oriented, so I will do a lot of other discussion on this particular point. This is a point from your syllabus, cumene phenol process, where phenol is commercially manufactured from cumene. The isopropyl benzene is first prepared from benzene by, or it is available, cumene is available in the market. You prepare from benzene with isopropyl chloride or even N-propyl chloride, aluminum chloride. There will be hydride shift, and it will get cumene. And once you get cumene, then you start your process. Is heated with air to form hydroperoxide. When there is one alpha hydrogen atom, at least one alpha hydrogen atom, then if you heat in presence of air, bubbling air, then this OO in oxygen, which is a diradical, which has two unpaired electrons, now is inserted in between carbon and hydrogen. Hydrogen is here, is shunted out to a mile apart, and it becomes the corresponding hydroperoxide. This is cumene hydroperoxide. This is a free radical mechanism. I will show you the mechanism. And then when it is treated with dilute sulfuric acid and distilled, the more volatile the ketone comes out with the residue containing phenol. So you write down this. I will use my pen and paper to go deeper into the subject. But here the precondition is you have to have at least one alpha hydrogen atom with respect to the benzene ring. Otherwise, because the benzylic free radical is stable, not one carbon apart. I mean, farther from the benzene ring, not in the beta position. Such such radicals are not stable at all.
Yes, sir.
Miss Samidha?
Yes, sir.
Now see the mechanism. See the mechanism. Well, if I make it a little bigger so that you can have a better look. Oh, why that has gone to. What has happened? Okay, forget. Now see, oxygen is a diradical. It abstracts an H dot. It abstracts an H dot. This is fish hook arrow. Homolytic cleavage of the CH bond happens to produce a hydroperoxide radical and a 3-degree carbon free radical, which is very, very stable. You can explain through resonance into the benzene ring that unpaired electron will move the orthopara position with same one electron shift, as well as hyperconjugation with the alpha hydrogen atoms of the two methyl groups. So it's a very stable free radical, 3-degree free radical. And then this hydroperoxide joins to form a bond. All are one electron shift. So you get the corresponding hydroperoxide, cumene hydroperoxide. Then a beautiful thing happens. When you add acid, there will be a rearrangement. There will be a rearrangement. Here, phenyl group moves from carbon to oxygen. Now, I'll tell you, because phenyl has a far greater migratory aptitude than the methyl groups. Therefore, phenyl migrates. But if there is no phenyl, the hydroperoxide will also undergo rearrangement. And I'll tell you the migratory aptitude number one is hydrogen. Hydride shift occurs first. There is no hydrogen here. Had there been one hydrogen, then the major product would have been the shift of hydrogen. And then after hydrogen comes phenyl. And then among phenyl, there will be, more is, the electron pushing nature, more is its livability. I mean, migratory aptitude. Nitrophenyl is having less migratory aptitude than simply phenyl, and methoxyphenyl would have more migratory aptitude than phenyl as well as nitrophenyl. Why? Because the driving force is the stability of the resulting carbocation, because you will see a carbocation is formed here. This is a 3-degree carbocation. Had the methyl gone, then it would have been a benzylic carbocation, but as you already know that a 3-degree carbocation is more stable than, of course, this will not be benzyl, I'm sorry. This oxygen, this carbocation, if methyl would have gone here, then the carbocation would have been, since phenyl has gone here, leaving behind the carbocation to the this carbon, if methyl would have gone to then leaving behind the carbocation here. Yes, of course it is benzylic position, but the migratory aptitude of the phenyl is greater than methyl, because electron density due to pi electron cloud is high. So more the electron density of the group, it has got a greater migratory aptitude. So I will tell you in other examples. So what happens then, adding water will add to here, and then deprotonation and proton exchange, that will make you phenol and acetone. I will be showing how to write this mechanism now in my copy, in my pen and paper. This I'm showing here. O2 is a diradical, and it will abstract a hydrogen atom to produce a tertiary free radical with OOH monoradical. Then they will combine. All are one electron shift to produce the corresponding hydroperoxide. Then when you treat it with acid, then this will be protonated. This will be protonated. This is a 2 electron shift. 1 electron shift is over now. 2 electron shift follows. Now ready for the water loss. Here is the best, one of the important steps is the rearrangement. And I will tell you the migratory aptitude. I'll write down here. The phenyl carbanion migrates to this oxygen, thereby eliminating water. Now the rearrangement, I showed you the sign of rearrangement. When a particular group leaps from one position to the other position, it is called rearrangement, where you find a stable carbocation. Of course, this carbocation is not only stable by hyperconjugation of the 6 beta hydrogen, this is an alpha hydrogen atoms, but also by resonance with oxygen. It will be bonded to, this is bonded to benzene ring now with one, and of course water has been already lost. So why should I make it a tilted one? Why not straight one? Because water is already gone. Now see what happens when migration occurs. There will be no charge on oxygen, because this group goes as phenyl carbanion, and another, it gains 1 electron and loses 1 electron. So there is no question of any charge developing on this oxygen. And but the charge develops in this. So carbocation is formed. water is gone. And then there is water will attack as a nucleophile. So it will be a protonated alcohol. I mean, see how it is happening with slowly how phenol is going to be formed. You see, then there will be a proton exchange. So the proton exchange, this phenoxyproton will be protonated, leaving behind this neutral. Now this will be protonated, ready for the formation of phenol. Then what happens? Are you writing?
Yes, sir.
Yes, sir.
Then what happens? This will come and this will be neutralizing the positive charge, where there is one more step. Phenol is already formed with one step so protonated acetone, but that will release this catalyst. I mean, H plus acts as a catalyst. So H plus goes out. Of course, you become very strict. Then you take the help of water or HSO4 minus, which is there as base to remove. I'm not showing that. Simply showing minus H plus to show you how acetone is distilled out. Now, in general, let me reaction of hydroperoxide with acids and with acid, usually dilute sulfuric acid. So the migratory aptitude, have you finished this?
Yes, sir.
First radical mechanism up till hydroperoxide is formed, then normal mechanism. Then migratory aptitude during the carbon to oxygen rearrangement shift is first hydrogen, then phenyl, then alkyl. And in phenyl, in this uh, plus R phenyl is greater than phenyl is greater than minus R phenyl, like nitro, cyano, like OMe, etc. So because ultimately when nitro will left out, supposing I will give you, and let me first say among alkyl, no doubt 3 degree is greater than 2 degree, greater than 1 degree. If 3 degree goes, 1 degree remains or 2 degree remains, there will be more alpha hydrogen atoms, so the carbocation will find more conjugating hyperconjugation structures to stabilize it. So this is the thing. But let me ask you a question. Supposing we have this hydroperoxide, there are two phenyl groups. There was one hydrogen we have produced already, and there is one nitrophenyl, and the other two are phenyl. Then we treat it with sulfuric acid. Then predict the major product. Between the two phenyl groups and the nitrophenyl, paranitrophenyl, which is having greater migratory aptitude. Yes?
Paranitro.
Paranitrophenyl has a greater migratory aptitude than phenyl. Then obviously this will move. I am not showing the mechanism. This will move and this will go as water. And ultimately another water will join here. And this portion will be converted to ketone. and this phenol will be paranitrophenol. So the phenol part will be paranitrophenol. This is not discussed to the plus 2 students or class 12 students who are not studying in a very deep-rooted analytical manner. Because in IIT Advanced, once an examiner, sorry, question setter finds there is cumin phenol process, you cannot prevent him to set questions with different aryl groups, aryl groups, and know whether you have studied that reaction very thoroughly or not. So the phenolic compound will be paranitrophenol, not phenol. And the ketone is diphenyl ketone or benzophenone. This is called benzophenone or diphenyl ketone, and this is paranitrophenol. Right? You understood?
Yes, sir.
Supposing I'll give you this one. Supposing we took benzyl alcohol and do the same thing. So once or else we took yes, we took this. Instead of taking cumin, we took ethyl benzene. Ethyl benzene was first treated with oxygen gas at high temperature to produce the hydroperoxide group at the alpha position. Then we subject it to acidic, it's not degradation process, I mean, the rearrangement process. So tell me which one is the major pair, which one will migrate, and which ketone will be formed.
Sir, hydrogen.
What?
Sir,
Obviously.
hydrogen.
So what are the products? What ketone and question of phenol or any, because this will go as water. This hydride will shift, right, to this oxygen.
Yes, sir.
And then what will happen? Since hydrogen, oxygen, there will be OH. And then C to the mechanism. The other product, you already have known that acetophenone will be formed. This is the carbocation formed and OH, right?
Yes, sir.
And then nothing will happen, this will go for, there will be loss of H plus, only H plus. This has already been lost as water. So there is nothing, no phenyl, no alkyl, nothing connected to O simply. So there is no question of any, other thing. Of course, water will attack here, and this will be OH, and same thing. I'm just trying to impress that had there been any other thing, this oxygen would have protonated, but since the product is water, so there is no point in extending further, so that you get this. And then it goes, so water is lost. The only product is water. Two water. First step water, in the last step also water. Right?
Yes, sir.
So you get acetophenone here plus water. Nothing else. No organic compound. You got it?
Yes, sir.
So in this similar manner, Samita, you understood?
Yes, sir.
In this similar manner, if you find that here is a compound, no, I will not put any aromatic because aromatic has greater aptitude. Supposing this is methyl, this is isopropyl, this is tert butyl. So, and this is hydroperoxide. Then obviously, without going into the mechanistic details, we can write down. So this will go, So the alcohol, here will be alcohol will be produced, and this will be ketone, because this carbocation has more number of alpha hydrogen atom. Therefore, 3 degree has more migratory aptitude. For that reason, stability of the resulting carbocation, and of course its bulk, it will leave sooner than later. So this will be ketone, and this will be the third butyl alcohol. Okay?
Yes, sir.
So then we will be going to the other methods of preparation. Ready?
Yes, sir.
Yes, sir.
I'll be using the slide now, the PowerPoint slide to. Now this method, actually, what is really done in the commercial method, we don't take, we prepare cumin by this method, not by taking not by any Friedel-Crafts reaction. This is electrophilic, no doubt, substitution, but it's not called Friedel-Crafts reaction. Aluminum chloride is not used here. Propene with phosphoric acid, so that it will produce isopropyl carbocation, and electrophilic substitution will happen to produce cumin, and then things are same. You can write down this one, how really cumin is prepared in the commercial process. Not, Friedel-Crafts reaction is a laboratory process, mostly. But the commercial process of getting cumin is taking alkene, propene with phosphoric acid. You need a protonation, and you don't take a strong acid like sulfuric acid. It will damage the double bond. So a weak acid like phosphoric acid does the job. It produces the isopropyl carbocation, and that undergoes the electrophilic substitution, benzene ring, to form cumin. Over.
Yes, sir.
Samidha?
Yes, sir.
Now see, this is another method. We already know in the preparation of chlorobenzene, we also use this BDC, benzene diazonium chloride, although we will be doing this in a very systematic manner in our chapter amines. But you know that an aniline reacts with nitrous acid at ice cold water to produce BDC. This is a covalent structure, but the more stable one is the ionic structure, N triple bond N, and this N will carry plus, and Cl minus will be out. So whatever it may be, it is benzene diazonium chloride. When you add water and warm it, so this will undergo SN1 reaction, nitrogen will escape, chloride will go, and OH will be joining. So you get phenol from BDC by simple SN1 process. Just write down in haste. That will be the end of our preparation of phenol. And of course, we have not forgotten that during the fractionation of the coal tar, destructive distillation of coal, and we get so many aromatic compounds, the light oil, the middle oil, the heavy oil. We have seen that in the chemistry of benzene. There, we learned that in the middle oil portion, there will be phenol, carbolic acid, which can be separated. You can just have a look to the Areen's file, you will find the fractionation. What fractionation? Is it petroleum oil or coal? What? Who can tell me whose fractionation produces three or four important things. First, the light oil, which contains mostly arenes, benzene, toluene, and then middle oil, then heavy oil, and then pitch. So, who can tell me?
Yes, sir.
What is, sir? You kidding me? Oh, yeah. Well, so I do remember, yeah, I have given the fractionation of coal tar. The destructive distillation of coal produces coal gas, which contains mostly methane and other things. And then the in the other distillate part, there will be ammonia liquor. Then the heavy part down is coal tar. That when you, again, the primary ingredient is coal, then one fraction is coal tar. Coal tar is fractionally distilled. This is destructive distillation in absence of air. Fractionally distilled with coal tar produces the middle oil, the carbolic oil that contains phenol. Remember this. The middle oil portion of the coal tar distillation product, the light oil contains the arenes. The middle oil contains phenols as well as naphthalene. The heavy oil contains also other phenols like cresols more, naphthalene to small extent. Then the anthracene oil or the creosote, green oil, I'm sorry. Creosote is heavy oil. So there will be crude light oil, middle oil, heavy oil, anthracene oil or green oil, then pitch. So write down somewhere that phenolic compounds are obtained from the heavy oil as well as the middle oil. Middle oil and heavy oil portion of coal tar distillation products. That's what I was trying to look at. Yes, not petroleum oil. It is coal tar, coal, then coal tar, then coal tar fractionation. Okay. Now, just you will write at home physical properties of phenol. It is a colorless solid having a very low melting point. In summer season, it becomes a liquid because in India and in many countries close to the equator, they have more than 40 degree during summer, so it melts. And boiling point is, of course, high 181.7. Boiling point greater than hexanol, although it contains same number of carbon atoms, but the hydrogen atoms are more. But because benzene is more polarizable, having pi electron cloud, therefore phenol has a greater boiling point than hexanol, but closer to heptanol, having one carbon atom more. But phenol turns pink. Whenever you open the bottle of phenol, it will not only look like a sticky solid, but it will be looking pink. The pink color, slight pink color that develops due to continuous use opening the bottle, and that is called the aerial oxidation. Air oxidation happens to partially convert phenol into benzoquinone, parabenzoquinone. I'll put it in the one of the equations in the uh, chemical properties. It is moderately soluble in water, though there is hydrogen bonding, but the benzene part is aromatic and that is hydrophobic, so it is not highly soluble, but slightly soluble in water due to benzene ring, which is hydrophobic, more soluble in organic solvents like alcohol and ether. Now, interestingly, let me make it a little bigger. Phenol is more acidic than alcohol. You already know it is a weak acid, and the phenols are at least 10 to the power 6 times, a million times more acidic than alcohols. And because you know the reason, the phenoxide ion is stabilized by resonance, 4 resonance structures. Therefore, the dissociation of OH bond is facilitated. While in alcohol, the OH bond is not dissociated to that extent, as the alkoxide ion is destabilized by plus I effect, and uh, and there is no such stabilization factor like phenoxide ion. Phenol reacts not only with active metals like sodium, potassium, but also with sodium hydroxide, potassium hydroxide, alkali, which alcohols never ever to form the phenoxide salt. Alcohols do not react with NaOH and KOH. Phenol does not liberate carbon dioxide gas with sodium bicarbonate or sodium carbonate that carboxylic acid does. We'll see how carboxylic acids are tested by adding sodium bicarbonate solution or sodium carbonate solution. You get effervescence. That effervescence comes from the carbonates that you add, not from the carboxylic acid that is present in that structure. Rather, carboxylic acid salts are produced. But interestingly, I think somewhere we have discussed phenol does react with sodium carbonate, doesn't evolve carbon dioxide, but does react with sodium carbonate. We say it dissolves in sodium carbonate as well as sodium bicarbonate, but no carbon dioxide is, and no, not as well as, it does not dissolve in sodium bicarbonate, does not produce carbon dioxide in any of the either this or that, but reacts and dissolves in sodium carbonate because carbonate, phenol as an acid is a stronger acid than carbonic acid. So if you look to this order, phenol is weaker acid than carbonic acid. Carbonic acid lies in between carboxylic acid, aliphatic carboxylic acids, and phenol. Of course, aromatic, aliphatic, they will come together. Carboxylic acids and phenol, in between comes this. So, now since carbonic acid is a stronger base, a stronger acid than phenol, The phenol can displace carbonic acid. Had carbonic acid been displaced, then carbon dioxide will be automatically what? Because carbonic acid is unstable. Such a thing doesn't happen when we react with mm, mm, carbonate ion. Bicarbonate is formed. So compared to phenol and acidic property of bicarbonate ion, looking to the pKa2, Ka2 of carbonic acid, phenol is stronger than. When we say phenol is weaker than carbonic acid, we compare with the pKa1 of carbonic acid. But coming to the comparison between phenol and bicarbonate ion, phenol is stronger than bicarbonate ion. Therefore, such a reaction happens, but no carbonic acid formation, no carbon dioxide evolution. So this is important. You write down at home all these things. Sodium gives sodium phenoxide. Sodium hydroxide also gives sodium phenoxide. And therefore, if you want to get back phenol, in case of carboxylic acid salt, you need to add strong acid like dilute sulfuric acid. Here, there is no necessity. Simply, you can pass carbon dioxide gas. Bubble carbon dioxide gas, carbonic acid will be formed. Carbonic acid is more acidic than phenol, so displacement will occur and OH will be formed. So, by simply treating phenoxide salt with carbon dioxide water, you get back phenol. You just write down this, leave some space for writing this acidic property of phenol, and then write down these structures, because we are still having 10 minutes time. I'm sure we'll not be able to finish this, but doesn't matter. We'll take a little time, maybe 30 minutes to finish phenols and then enter into ethers. So the coming class will be ethers partly, and the next class will be the end of ether. So the big chapter, alcohols, phenols, and ethers will be over, and we'll go for the test, because we have not done any test in organic. Have you given the test on haloarenes and haloalkanes? No?
No, sir.
No. So we'll make a mega test, haloalkanes, haloarenes, and then alcohols, ethers, and phenols. And of course, the tests, organic tests in class 12 will always have some connectivity with class 11 program. So you can't rule out that I will only prepare question at, which will be found in the NCERT book on class 12. These are organic things are all related. Acetylene is in class 11, but once you put it mercuric salt and acidic medium warm it, you get acetaldehyde. Acetaldehyde in class 12, aldehyde is in class 2. And aldehyde is also in alcohols, because formaldehyde or any other aldehyde on reduction by La will produce primary alcohol. And ketones will produce secondary alcohol with La or any other similar reducing agents. Even sodium borohydride. Sodium borohydride cannot reduce esters and carboxylic acids, but it can very well reduce ketones and aldehydes. Over.
Yes, sir.
Sami?
Yes, sir.
Now see, esterification is another property where the OH bond is broken, just like formation of salt. Esterification also, the OH bond is broken. Just like alcohol, phenol will retain the oxygen, but the carboxylic acid part will lose the oxygen, the OH. Of course, one double bond O will be there, but the other OH will be lost. So whenever phenol reacts with a carboxylic acid, you get the phenyl ester, phenyl alkanoate. You can also take, instead of dehydration of reaction, you can take acid chloride and just add pyridine to remove a Cl product to drive the equilibrium to the right. So you get the same thing. These mechanisms will be taught in detail, discussed in detail in our carboxylic acid chapter, the acyl substitution. You can write down this page, and I think we will not, we'll give a break. We were in, supposing in gear 4, we'll be slowing down and by reducing the gear number 3 to 2 to 1 and then stop. Done? Only the next page we'll be doing, only one page, then we'll stop. This is the phenyl ester. Phenyl acetate, phenyl propionate, phenyl butyrate, phenyl pentanoate, and all that. The carboxyl part is aliphatic, but the alkyl part, the alkoxy part, the alkyl part, in the naming we don't say alkoxy part because the alkanoate contains both the O's. Both the O's are included in the naming alkanoate, OAT, OAT, OATE, OAT, TE. Done?
Yes, sir.
Done?
Yes, sir.
Yes, sir.
Then see, the same continues. Instead of taking acid chloride or carboxylic acid, you can take another good substrate is acid anhydride. These are the two best substrates, acid chloride and acid anhydride. Because we will see in our carboxylic acid chapter, the livability of halide ion and alkanoate ion is very good. Therefore, you can also use anhydride and phenol to give the same thing. But this is called the acetylation, benzoylation, same esterification. But we say, particularly we use acetic anhydride. This is a general thing, any anhydride, any anhydride. If you take acetic anhydride, it will, or acetyl chloride, I have not use here a general formula, but here the specific, if you take acetic anhydride or acetyl chloride, you get phenyl acetate. Instead of taking, acetyl chloride, is not written. You take benzoyl chloride, you will get benzoic ester, benzoate. All cases will be phenyl ester, but this will be aromatic carboxylic acid, this is be aliphatic carboxylic acid. And if you take salicylic acid, which is orthohydroxybenzoic acid, and do the acetylation with acetic anhydride, then this OH will go and one acetate ion will go as they will combine, go as acetic acid, and one acetyl group will be bonded to O to give you OCOCH3. This is called acetyl salicylic acid. Acetyl salicylic acid. Or you can call ortho or 2 acetyloxy. Acetyloxy benzoic acid, which is famously called acetyl salicylic acid. And the aspirin that we take, which is present in the drug, painkiller drug, aspirin and related compounds. It's not paracetamol. Paracetamol is something different, which is nowadays used in a rampant manner for painkiller and fever reducing agent, that is analgesic and antipyretic, reduces fever both. But this is not that. Aspirin nowadays is used by old people like us who have some heart ailments to keep the blood thin regularly. The doctor, as I remember, recommends to take an aspirin every day. But it is a painkiller. It's simply an analgesic. এটা লিখে দিও, তারপরে আমি পড়েবা। Bye bye. করদবা। Now, hello and welcome. This is not for you who are in Zoom, but for those who are watching from the YouTube video. So thank you very much that some of you, I'm not a vociferous YouTuber who is keen to promote the YouTube's. Of course, I am interested that more subscribers should join my channel, undoubtedly. So, guys who have already subscribed to my channel, I am so happy and thankful to you. And those who have not, and you anticipate that you will be benefiting from these programs, or you can simply forward these useful discussions to some others, you can consider subscribing to my channel. This is SST Chemistry, and I am Sudhanshu Tripathi, by the way. By the way, I was teaching in Ravensa, the erstwhile Ravensa College. Now it is Ravensa University. And now I'm retired. Of course, since 2002, I took voluntary retirement, and I have been engaged in promoting science activities, particularly physical science activities in school. Particularly in the vernacular medium school, you might be wondering that throughout my lecture, I never used today Odia, because these two guys who are there with me, they are very conversant in listening to English from me. So I did not. But in most other cases, when I find I am inaccessible for the students who are studying in Odisha, but very good, very receptive, very, brilliant, then I come down to my language of the soil, Odia, which I love because I was born in this land of Odisha. I'm proud of being called as an Odia. Yeah. Well,
Yes.
over?
Yes, sir.
No, this is the end. Remember, this 12, slide number 12 is the last that we had today. Have a very good day, and we will resume on maybe we can we see tomorrow?
Yes, sir.
Samida?
So କାଲି ଆମର ଗୋଟେ class ଟେ ଅଛି.
Okay. Then no. Then it will be Kali afternoon.
Yes,
Can
sir.
you? When are you free? Are you going for any tour or any trip tomorrow?
No, sir.
So let me know the time.
Yes, sir.
Then I will communicate in the group, and if Rudra accepts that time, then we will have it, because others, they will watch the video. Bye bye.
Pranam,
Thank
sir.
you, sir.
Pranam.